Houdini is one of the most sophisticated animation packages ever to be used in the creation of blockbuster feature film effects. Are we really going to be able to teach you Houdini in 30 minutes? Well, probably not. But we are going to teach you enough to create a basic scene with lights and cameras. From there, you can move on to other videos that will show you how to make more useful effects like this, or this, or this. Now, we got a lot to cover in 30 minutes, so we're not going to waste any more time on the preamble. Let's just dig right in. Start by downloading Houdini Apprentice from the SideFX website, SideFX.com. Now, Houdini comes in several flavors. The Apprentice version is identical in functionality to the full version of Houdini. It just limits your output resolution and adds a watermark. We're actually recording using the Houdini Indie version. It's a great way for young studios with small annual revenue to get started with Houdini. Unlike the Apprentice version, it doesn't watermark your output, and its license allows you to use the results in commercial works. Once you've installed Houdini, you'll be asked to quickly authenticate your free license, and then you'll be on your way. There are several different layouts called desktops to work with in Houdini. We'll be using the technical layout throughout these videos. Enter Houdini's preferences, and in the General User Interface section, select Technical as the Startup Desktop and click Accept. Now that ensures that next time you launch Houdini, you're in the Technical Desktop layout. To switch to Technical in the current session, choose Desktop Technical. Oh, and if you mess your interface up by, say, accidentally deleting your Scene View tab, just choose Desktop, reload current desktop, and you'll be back in business. Before starting a new project, you should always have Houdini create the directory structure for you to help with housekeeping of your files. Choose File, New Project, give your project a name, and choose a location for the project on your hard drive. When you click Accept, Houdini will create all the folders listed for you inside the master project directory. Let's save an initial version of our scene. Now that your eyes are adjusting to the interface, anxiety might be kicking in as you survey the sheer mass of buttons and icons. But true to the style of these guides, we're going to focus only on what you need to know to get up and running. The rest you can discover as you go. Right out of the gate, let's get a 3D object to play with. Now, Houdini's keyboard shortcuts are context sensitive. In other words, what happens when you press a particular key on the keyboard may change based on where your mouse is hovering. Right now, hover your mouse pointer over the scene view and press the Tab key. A large list of building blocks for your 3D scene appears. As you hover your mouse over each menu item, you'll see submenus for the various items. Some of these you'll use regularly, some you may never need. In the Test Geometry section, you'll find a list of 4 sample objects you can use to experiment with as you build effects. The developers at SideFX have very sensibly chosen to provide a pig head, an inflatable pool dino dragon, a shader ball for testing shaders, and a squab, a cross between a lobster, a crab, and a squid, a thing to strike terror in the heart of even the most seasoned sea captain. We'll forego the somewhat unnerving pig head and squab and work with the innocuous rubber toy here. Once you've selected it from the list, click somewhere on the ground plane grid to create it. You'll also see a node added to the network view on the right. We'll get to that a little later. To see it in all its glory, click in the blank space of the 3D view to deselect it. Now let's take a quick look at the most important buttons around the scene view. At top left are 3 selection buttons. There's Object Select for selecting and working with entire objects. Then we have Geometry Select for working with the points, edges, and polygons that make up objects. By holding the mouse down over Geometry Select, you can choose the specific kind of geometry you want to work with. Primitives is Houdini speak for a basic unit of geometry, typically a polygon. In other 3D digital content creation software, polygons are just referred to as polygons, while primitive means a basic object like a cube, a cylinder, or a torus. So if you've worked with 3D elsewhere, it's important you understand what Houdini means by primitive. The final button is for dynamic object selection, which we won't be concerning ourselves with right now. Go ahead and click back on Object Select. There are several different tools for moving and snapping below the Select tool, but we'll just focus on one uber tool, the Handle tool. If it isn't already selected, select the Handle tool. Now make sure your rubber toy is selected. You'll see transform widgets superimposed over the object. Press the Y key to cycle between Translate controls, Translate and Rotate controls, and Translate and Scale controls. Go ahead and experiment by dragging on different handles in the view, toggling between the three views with the Y key. Some handles will constrain adjustments to one axis, others two axes, and others all three axes at once. We won't go over the handles individually since you can figure them out for yourself by experimenting, with one exception. To scale in just one direction, you need to grab this portion of the handle in the axis direction you want to scale. It's kind of tucked away, so we figured we'd save you some frustration and call it out. Now, chances are, after playing with all these handles, your rubber toy has been badly bent out of shape. The good news is you can manually enter numbers to set it right. Over in the Parameters view, click and enter 0 in the translation field for the x-axis, followed by the Enter key. Now click into the y-axis, enter 0 again, and then press Tab to jump to the z-axis and 0 it out as well. In Houdini, X, Y, and Z correspond to the left-right direction, up-down direction, and forward-backward direction, respectively. A quicker way to reset is to right-click on the parameter label and choose Revert to Defaults. We'll do that for rotation and scale. Your rubber toy is back in shape and centered on the ground plane grid. Okay, let's say you wanted to carefully rotate the toy around the y-axis. If you click down on the y-axis field with the middle mouse button, the scroll wheel on most mice, you can use Houdini's ladder system to adjust. Now, if you don't have a 3-button mouse, well, you really need one to work with Houdini. Enough said. By mousing up and down the ladder, you can choose just how fine an adjustment you want to make. This works in entry fields throughout Houdini. Let's add another object to the scene. Control-click on a torus from the Create tab at top left. Control-clicking automatically places it in the center of the scene instead of having to click a second time on the ground plane like we did for the rubber toy. Use the move handles to shift it out of your toy's way. So far, we've been looking at our scene from a single angle. But what if you want to see your toy from behind without changing its positioning in the scene? Now, that's where the view controls come in. To access the View tool, hold down the spacebar. When you do, the View tool is activated for as long as the spacebar is held down. Now, for the following set of mouse and keyboard commands, we're making the assumption that you're already holding the spacebar. Unless you actually click on the View tool icon, these commands won't work without the spacebar held down. To rotate the view, sometimes called tumbling or rolling, just click and drag the left mouse button. To pan the view, middle mouse drag, and to zoom the view, either drag the right mouse button or scroll the scroll wheel. Sometimes things may get a little lost if you zoom too close or too far. To quickly frame an object in the view, select it and press F, while still holding that spacebar, of course. To frame all objects, press the A key. And when you're done adjusting the view, release the spacebar before carpal tunnel sets in. Alright, so we know how to move objects about to set up a scene, but what about lights and cameras? Let's start by adding a ground plane so we have something on which to cast our shadows. Control-click a grid in the Create tab to add it. Select the Handle tool if it's not already active, and toggle to the Scale handles with the Y key. We'll scale it up a little in the XZ plane. In our case, the toy is half underground now, so we'll select it and just move it up a little. Now let's add a light. First, we'll turn on something called the Construction plane to help visualize our placement. From the Lights and Cameras tab, click on a spotlight. The help tip at the bottom of the viewer tells you what to do. Drag the crosshair to the position on the ground plane that you want your light, then hold down the Shift key to set its height. When you're happy, click to create the light. The transform controls for a light have two main widgets, one for the light itself and one for the target of the light's beam. Move and rotate either of these to position the light as desired. There are a couple more options we need to discuss as you adjust the light. First, the transform handles default to what's called object or local space. That means they're aligned to the rotation of the object, in this case, the spotlight. Now, you might find it more natural if the handles line up with the scene's X, Y, and Z axes. Just right-click on a handle and choose Align Handle, World, and the handles will now line up with the scene. The perspective view is fine for a lot of things, but you'll often want to switch to 2, 3, or 4 separate orthographic views to get a better idea of exactly where your objects are in space. Select a set of views from this menu. Each of the views can be adjusted individually using the standard view controls with spacebar held down. Note the keyboard shortcuts listed next to each layout that will allow you to quickly jump between them as needed. The construction grid can get a little annoying when you're lighting, so you can click this button to disable it. Let's take a look at a few more viewer settings that will help you work more efficiently. This menu allows you to choose from a variety of preview styles, from simple wireframes to fully shaded to shaded with overlaid wireframe. As you start dealing more with individual points and polygons, these other modes will be useful. Right now, we'll stick to smooth shaded. Then on the right side, we have different lighting options, from no scene lighting to basic lighting to high quality lighting. Click and hold these buttons for additional options. You may notice some banding or stepping in the shadows of your viewer. To fix this, press D with your mouse over the viewer to open the display options. In the Scene tab, enable HDR rendering. This will smooth out that banding. On more complex scenes, you may need to disable HDR rendering and reduce the lighting quality setting to improve performance. But since we're working with just a couple of objects here, we'll leave them all on. Make sure your light is still selected in your scene and take a look at the parameters view. You can click the color swatch to change the light's color, adjust its intensity, and modify spotlight values like cone angle, delta, and roll-off. You'll also notice other tabs for area light and distant light properties. That's because the type of light can be changed simply by choosing a different option from the type menu. Here, we'll select Tube and deactivate the spotlight. If we readjust intensity, we end up with something much more like a fluorescent tube. We can adjust its length in the area light options. And let's quickly add a distant light with a low intensity for a little ambient lighting. Now that we have a few objects in the scene, it's time to address probably the most significant part of Houdini, the network view. Like Fusion and Nuke, Houdini works via networks of nodes. If you're not familiar with nodes, you'll want to review our quick video on node-based compositing fundamentals. Even though we're dealing with 3D objects here, the principles are exactly the same. Right now, the network view has a node for each of the items in our scene. If you can't see them all, press O to access the network overview, which provides a bird's eye view of all your nodes. Drag in the overview to center the nodes, and then use the same middle mouse pan and right mouse zoom shortcuts we used in the 3D scene viewer to get them all visible on screen. You'll see each of the items in our scene has a label next to it. You can double-click to rename them. When you mouse over one of the nodes, you'll see the node ring,
a group of buttons that gives you access to basic node functions even if you're zoomed way out. To hide one of the items, click the display toggle in the node ring. To protect an item from being selected and unintentionally moved, disable its selectable toggle. Click again to re-enable selection. The Information button gives you access to various statistics about the node. This becomes much more important as you get into modeling and particle effects. This is also where you add custom notes about an item that you can make visible in the node network. You can pin several of these information windows open, and they remain visible until you click the Information button again or close the window via its header bar. Finally, click a node's center and its properties will appear in the Parameters view.
Now, this view of your scene items is just one of several node networks in Houdini. The old school Houdini term for these networks is contexts, but you can really think of the various contexts as work tables for doing different things. So here we have the scene network for laying out the scene. But by clicking the network selection view, we can find another work table for putting together shaders, the surface textures for your objects, and other networks for other tasks like compositing. You'll get to know other networks as you need them, but for now, let's head back to the objects network that shows us our scene elements. It turns out that these innocent-looking nodes are actually hiding a dark secret. They're containers for other nodes. Don't panic, the principle is actually straightforward. Double-click Rubber Toy to go inside to its gizzards.
By doing so, we've drilled down into what's called a geometry network.
To jump back up to the scene level, press the U key or click back on the OBJ header in the breadcrumb trail at top. Double-click Donut and you'll see it too has a single node hidden inside. This is the node that actually creates the points and polygons that make up the torus. Let's try something out. Select the torus node and press Ctrl X on a PC or Command X on a Mac to cut the torus from the view. It disappears from the network view and the scene viewer. Press U to go back to the main objects network view. The donut node is still there, but now it's an empty container. We cut the actual geometry out of it. Double-click Rubber Toy to enter its container. Now press Command V to paste. The torus is pasted in alongside the rubber toy. But now, the rubber toy has disappeared from the scene viewer. That's because each container can only display one final node.
And you'll see that the display indicator for torus 1 is blue, while the display toggle for the rubber toy is blank. Click the display toggle in Rubber Toy's node ring, and now it shows in the scene view while the torus disappears. By the way, you may notice additional node ring options for the nodes here at the geometry level. We'll ignore those for now.
Well, let's say we're trying to build a special kind of rubber toy that includes the donut ring as an integrated part. How do we get both of these objects to be visible at the same time? Well, just like we would in a node-based compositor. We use a merge node. Right-click on the small output link of the test geometry node that creates our rubber toy and type MER. All nodes with those letters are listed, and you can move through the search results with the up and down arrow keys. We want the top one, the plain vanilla merge. So select it and press Enter. Now click in the network view where you want to drop the new node. Finally, click the output of the torus node and then click the input to the merge to connect it as well. Now, apart from a wireframe ghost, you still can't see both objects combined. That's because the toy is still selected as the final output for the group of nodes. Click the display toggle for merge 1, and the two elements are finally combined. This, of course, is just the start. We can add all kinds of additional nodes to customize the properties of an object and its components as we build objects inside of Houdini. If we press U to move back up to our main scene view, we can select and delete the donut node by pressing the delete key, since it's now just an empty shell. And if we now select the rubber toy and attempt to move, rotate, or scale it, both the toy and the torus move as if they're the same object, which, as far as Houdini is concerned, is exactly the case. So far, we've just been looking at a rough preview of our scene. Houdini includes a powerful rendering system called Mantra for final rendering. But before we render, let's add a camera and frame our shot. In the scene view, choose New Camera from the camera menu. A camera is created and its properties populate the parameters view. We're now looking through the new camera in the scene viewer. Clicking over to the View tab, we can make the usual changes to the camera, such as focal length and aperture. But now, if we try to adjust the camera's framing in the viewer, Houdini will snap back to no cam, the standard perspective view, instead of moving our camera's position. This is in fact to protect you from accidentally reframing your camera, when all you meant to do was look at the scene from a different angle. If you do want to reframe your camera, and right now we do, select your camera from the camera menu, then lock it to the viewer using the lock button at right. Now, as you tumble and pan the view, you're actually reframing the camera that you'll be using for the render. Okay, time to render. But before we do, we need to tell Houdini what we want to render to.
Houdini supports third-party renderers in addition to its native renderer Mantra,
So we'll need to specify that we're rendering to Mantra. For this, we use the Out network view. It's empty, so choose Render, Create Render Node, Mantra PBR. PBR stands for Physically Based Rendering and will give you the most realistic render without any heavy tweaking of settings up front. At this point, we could choose an output file path and click Render to Disk, or click Render to Mplay to preview it in a flipbook player. But because we're going to be doing some tweaking to the shot, flip over to the Render View tab. Confirm that it's set to render to Mantra 1, the render node you just added a moment ago, and that it's looking through our camera, Cam 1. Click Render, and away it goes. The scene's way too dark, so we'll jump back to the scene context and select our fluorescent tube. Notice as we adjust the intensity, the render view automatically updates the render for us. Now that we see our final render quality, the torus is looking really dull. It could use some texture. Creating custom shaders is a whole subject unto itself, but as you're getting started, Houdini provides a host of useful presets. Click over to the Material palette and then click and drag a preset onto the torus.
We'll try blue cloth. And let's give our ground plane a coated metal paint look.
Now, there is another problem with the torus. It looks too angular. That's because there aren't enough polygons in the base model to make it look like a curved surface. There are several ways to tackle this. Here's the easiest first. Back in the scene view, select the rubber toy and in its parameters, switch to the Render tab. Enable Render Polygons as subdivisions. Mantra now subdivides those large angular polygons into multiple smooth ones. The problem with that solution is that the rubber toy also gets subdivided. It didn't need it, and forcing Houdini to subdivide it as well creates a whole lot of unnecessary polygons, and more polygons means longer render times. We'll deselect Render Polygons as subdivisions. Instead, let's double-click the rubber toy container to dive into it. Here, we can either increase the number of rows and columns in the torus to make it smoother, or, and let's undo that last change, we can right-click on the output to the torus and type Subdivide to add a subdivide node. Here we actually have control of how deep we subdivide. A value of 3 is usually sufficient for final renders. And we're only subdividing the torus since it's the only thing upstream from the subdivide node. Now we have just enough time to do some animation. First, will move back up to the scene level. Make sure your timeline playhead is set to frame 1. Switch back to the scene view, select the rubber toy, and with the handle tool, drag it left. We can set a keyframe for Translate by Alt-clicking the label for Translate in the Transform tab of Rubber Toy's properties. Now move to frame 30 by dragging in the timeline. We'll middle mouse click the X transform and use the ladder to shift our toy to the right, then Alt-click Translate again to set another key.
Drag through the frames in between, and sure enough,
we have animation. Done. We'll even pop back to the out context, select our mantra node, and enable motion blur to prove things are moving. Now to adjust the animation, switch back to the object context and make sure the rubber toy container is selected. Then choose Window, Animation Editor. The Animation Curve Editor automatically identifies the animated parameter in the rubber toy and adds the translate curve. Drag Bezier handles to adjust the slope of the curve, the center of a keyframe to adjust its value, or the vertical handle connected to the keyframe to move it in time. Now, this is not going to win us any Academy Awards, but let's assume for the sake of argument that we're ready to render our final version out to disk. Switch back to the out context and make sure you're looking at the properties in the Images subtab. Because we had Houdini create a project structure right at the beginning, Mantra will automatically save the images to the render folder in your project directory. The strange dollar symbols just mean each of the names after the dollar sign is a placeholder. At render time, $hip will be replaced with the path to the project file. $hip name will be replaced with the name of the project. $OS will be replaced with the current operator's name, in this case, Mantra1, and $F4 will be replaced with a 4-digit padded sequence of frame numbers. And we don't really need the node name, so let's replace that bit with test01. We do need the frame number. Without it, we wouldn't have animated sequential frames. Houdini automatically uses EXRs as a file format, which is good since it's the industry standard format for storing high dynamic range image data. But if you want a more common format, you can always change this to, say, PNG, at the expense of that extra dynamic range. We'll change to render frame range instead of render current frame.
now we only have animation from frames 1 to 60.
So there's no need to render more than that. But if you try typing 60 into the end frame box, it'll keep reverting to the scene's default frame length. That's because there's an expression hiding in there, linking the render out point to the scene out point. If you click the Start End ink label, it'll change to showing you the expressions. Delete the $F_end expression and replace with the number
60 to render out just the first 60 frames.
Click Render to Disk, and the render begins. When it's done, you'll find your files in the render folder of your project directory.